Hello everyone, the first experiment is the synchronous machines. You can see the synchronous rotor on the top with F1 and F2 for the two sides of the windings for the rotor, and then also you can see the stator with the three windings V, U, V, W. It is possible to power U, V, W using the test pins on the board. So the first experiment is connection and starting. In this case, U, V, and W are powered from the three-phase power supply, but we do not connect anything to the rotor winding yet. So I have put a marker, like a black marker, black line on the top of the rotor, on the shaft. So when the rotor starts rotating, you should be able to see this line rotating or not. So for the first part, I'm going to turn on the power. So the power is on. I can, if I touch it, I can like feel some humming in the rotor, but you can see that the line is not moving. On the next part, I'm going to turn the power off and then connect the wires to the F1 and F2. So F2 goes to 15 volt and F1 goes to the ground. I'm gonna remove the wires to make sure it doesn't rotate around the rotor. Now I'm going to turn on the power, and you can see what happens to the rotor. Pay attention to the line mark on top of the rotor shaft, and you should be able to answer the question. So I'm going to stop the motor here, and in next part I am going to choose a motor unit control. So I'll go to instrument, motor control, and in this part what I can do is I'm going to set the frequency to 50 Hertz, and then I'm going to say the ramp speed to be 30. So this is the speed, the ramp that shows the increase of the speed, and I'm going to say the starting voltage to be 6 volt. So if you pay attention to the marker and see how the speed changes when I go on. So I'm going to turn it on now. Okay. So next experiment is synchronous operation, where I'm going to show you how the synchronous operation works. In order to do that, I'm going to use a motor control unit where I can set the starting voltage from 6 volt, the cutoff frequency to 75 volt here, and 75 Hertz, sorry. And then I'm going to set the power supply frequency to 10 Hertz. So what happens now, if you look at the rotor, so the motor started rotating, and you can see from the markers on the top. What I'm going to do now, I'm going to use a stroboscope interface to measure the speed. And then there is a table that I have to change the frequency from 10 Hertz to 70 Hertz and measure the speed and put it here. So I start from like 588, and I'm going to turn on the stroboscope. So you can see, pay attention to the marker, the line marker on the top. The moment I aim it with the stroboscope, you see that you are able to see the line. So it means that somehow we are close to the speed. But what I'm going to do, I'm going to just go a little bit higher. And here is where I see the line almost stopped. I don't know if you're able to properly see it in the video, but the speed is 606 for 10 Hertz. Then I'm gonna stop the power, change the frequency to 20 Hertz, and I'm gonna run it. So now I have to increase the stroboscope to, I'm gonna increase it to like 1200 almost. So here you see the line almost stopped. I'm gonna go a little bit up. Here is perfect. So 1200 RPM is for 20 Hertz. Now I'm gonna stop again, go to 30 Hertz. I'm gonna run it now, and on stroboscope I'm gonna go all the way to around 1800. You see the line started to go, rotate slowly. This is almost, yeah, perfect here, 1800. So at 1800 you don't see even the line moving. Then I'm gonna stop, go to 40 Hertz, run it, and on the stroboscope I'm gonna go all the way to 2400. You see the line is starting to go slower. Okay, 2400, the line stops completely. Going to 60 Hertz. It's running nicely, and I'm gonna go to 3600 here. And you see right at 3600 the line stopped. Next experiment is the voltage and current measurement. So we are using the small resistor board to measure the current going through the W line, and also we are using the channel A to measure the voltage between U and that W. So channel A is showing the line voltage and channel B is showing the current. So on channel B, whatever you read, even though it looks like the voltage is the voltage that you're measuring, but it's equivalent to the current, because the small resistor board is using a resistor to convert the current to voltage, and the conversion is done by the oscilloscope. So whatever value you read as the voltage is actually the current on channel B. So I am using a motor control unit set up for 50 Hertz, a starting voltage of 60, cutoff frequency of 75. I'm gonna run it. You can see that the rotor started started rotating, and the voltage and current signals appears on oscilloscope. So I'm gonna stop here so you could do the measurement. You have the scale for channel A, which is the voltage 10 volt, a scale for channel B, which is 500 millivolt, but this one you could consider it as 500 milliamp. So channel B, every block is showing 500 milliamp. So from there you can measure the voltage and current. Also you can measure the phase difference, which I assume that you know how to measure the phase difference between the voltage and current, and from there you can calculate the cos phi factor. Next experiment is the reluctance motor, and the first thing that we investigate is the generation of torque. In generation of torque experiment, we are connecting the U windings to 15 and ground, and you can see the reluctance rotor in the middle replaced with the previous rotor. So what happens, the experiment is asking us to rotate the rotor by hand 360 degree and release it, and you guys are supposed to find out if there are some like neutral positions that whenever I release the rotor is gonna stay there. So you can see the line is here, let's say almost at 9 o'clock. So I'm gonna give it a push to rotate to 360, and it stopped at, let's say, almost 4 o'clock or 3 o'clock, let's call it. So I'm going to give it another push. Again, went back to 3. Let's give it another push. 3, another push. Okay, now it went back to 9 o'clock. So it seems that 3 o'clock or 9 o'clock are the position. Next one is asking us to change the polarity. So the 15 and now, so I'm going to switch the 15 and ground on the U windings. So right now it is at 9 o'clock, so I'm going to give it a push. So 9 o'clock, give it a push. 9 o'clock, give it a push. 9 o'clock, give it a push. It seems it went at 2 o'clock, give it a push. 9 o'clock. So it seems that one of the neutral position was shifted. It was at 2 o'clock before. We switched the polarity and now it's at 4 o'clock, so you can use that to calculate the shift. Next experiment is switch reluctance machine. So here we have 3 relays, and at each point one of the relays is supposed to apply plus 15 volts to U or V or W windings. Depends on which winding is getting this 15 volt, you have a rotation on the rotor. And to control the relays, we are hooking up all the wires from the board to the relay section on the interface. So this part which you see number 1, 2, 3 with the relay symbols, this is the relay section. And in order to control this relay, it says click here. So when I click here, I see it says position 1, position 2. So there are 6 positions. If I click on each position, then the rotor is going to rotate to a specific position. And the reason is that is because when I click on position 2, the software is changing the relay. So for the first position, relay 1 is connecting U to 15 volt, and you can see that the position is at, let's say, 10 o'clock. I would say 10 o'clock. Then if I go to next position, it's 11 o'clock. If I go to, and for this one, you can see that both U and V are connected to the power supply. Position 3, only V is connected and we are at 2 o'clock. Position 4, we go to the 4 o'clock, and for this position V and W are connected to 15. Position 5, we went to 5 o'clock, and only W is connected to 15. And position 6, we are going to 8 o'clock, and the only, no, not only, is actually W and U that are connected to the 15 volt. Next experiment is about the asynchronous and synchronous operation modes. So in this experiment, we are going to supply the motor with the 14 volt and 50 hertz, and then we are going to use the stroboscope to measure the speed and see if the speed is in sync with the power supply or not, and then answer the question regarding the synchronous or asynchronous modes. So I'm going to, before that, please pay attention to the lines on the rotor. I put several lines, so when it starts rotating, of course the lines are going to be disappeared, but after I aim the stroboscope to the rotor, if the speed is in sync with the stroboscope, then those lines are gonna look like standing still to us. So I'm gonna run the motor, pay attention to the lines again. So you see that the lines disappeared, and now I'm going to set the stroboscope to 50 hertz, and I'm gonna aim it so the lines I can see. I'm trying to aim it from different angles because of the reflection. It might not be very easy to see it, but I can see that the line is standing perfectly still on top of the shaft, and I can visually see the line. I'm gonna again aim it with different angles, so see which one is more visible to you guys in the video. But here in the lab I can perfectly see the line without any problem, but because of the reflection, again, you might not be able to see it. Again, I'm doing my best to show you the line. Next experiment is the voltage and current measurement for the reluctance motor. So in this experiment, what we do the diagram and connection for 2 windings, but the other windings U and V, we connect it to channel A to measure the voltage across U and V. This is done by these 2 wires going to channel A, and also the current that is going from the V voltage, the V line, it's going through the small resistor board to measure the current. So this wire here is coming from V1 voltage going to the resistor board to measure the current going through this line. So we're gonna run the motor using the 50 Hertz and 14 volt voltage, and I'm gonna click on here. You can see that the rotor started rotating, and I'm gonna stop the voltage and current measurements. The red one, the red waveform is the current waveform from channel B. Every scale is 500. It says millivolts, but you know that because it's going to the small resistor board, this millivolt is equivalent to milliamp. So every square is 500 milliamp, and the blue one is the voltage, and every block or every square is 10 volt, and the 5 millisecond is the block for the time, the horizontal block. So you can use all these numbers to calculate the phase and also calculate the current and voltage. And after you calculate the phase, you can calculate the cosine of the phase between voltage and current to come up with the cos phi factor.